Good evening, ma'am.
Good evening.
Good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
So, how are you all?
Fine, ma'am.
Okay. First of all, please switch on your videos. If you have stable network connection, please switch on your videos. Yes, everyone. This way you
Ma'am,
will,
ma'am,
yes,
actually, I am joining through my mobile hotspot, so video is not supporting.
okay. Try joining with other device next time because when you switch on your videos, you'll be able to interact well and you'll feel that you are in the class. Okay.
Okay,
So
ma'am.
that way is better. Everyone else, very good. So, I will be dealing with the chemistry section for the 10th class science. And today we will start with first chapter only from this section, chemical reactions and equations. So, this chapter basically will help you understand what is chemical reaction and how we write chemical reactions. This chapter is a base for anything and everything that you are going to study in chemistry even in higher classes. What you will study in these classes or in this chapter, this you will learn by heart and you will use that almost every day in every aspect in chemistry in higher classes. So this is the foundation because from ninth and 10th only you start, separating the branches into chemistry, physics, and biology. Before that, you study only simple science. So, you will enjoy these classes. You will learn new concepts, new reactions. Even you will perform some experiments in your labs in schools. So, this is going to be very interesting chapter. So, all of you, you will have to interact well, answer questions, participate more. Then only the sessions will be helpful to you, and you will be able to enjoy the classes. Okay, right, everyone?
Yes.
Okay. So, we will start with chapter chemical reactions and equations. Can anyone tell me what do you mean by chemical reaction? Any idea? Anyone?
Ma'am, can I?
Yes,
Ma'am, a chemical reaction is a type of reaction where the reactants combine together to form a new substance, and which and it has a change in their chemical properties.
very good. That means you are aware with the idea of difference between physical change and chemical change, right? Anyone having doubt between physical change and chemical change?
No, ma'am.
Okay, very good. So, for example, if we see, we keep our milk in the house for a long time. Does it stay the same? No.
No, ma'am.
It,
It curdles.
yes. And can that curd go back into milk? No.
No, ma'am.
So, yes. So, can I say that this is a chemical reaction? Turning of milk into curd is an example of a chemical reaction. right? Now let us move on to, you must have seen this frying pan or tawa at your home. This is brand new and it looks like this. But after some time, if we notice, it looks somewhat like this. What has happened?
Ma'am, rusting.
Yeah, resting. So do you know the reaction that is happening behind? How this rusts?
Ma'am, oxidization.
Yes, the oxidation reaction. Very good. So everything that is happening around us, we can identify the things which are related to chemistry in that. Now we know that when a pan is rusting, there is a chemical reaction that is happening. That's why it gets rusted. For example, these are grapes and they are getting converted into this alcoholic drink through the process known as fermentation. What happens during fermentation? The grape juice is converted into this alcoholic beverage. So during fermentation, there is an organism known as yeast. It turns the sugars which are present in the grape juice into ethanol. That is a form of alcohol. That is, it forms an alcoholic drink, and that process is known as fermentation. So, this also is an example of chemical reaction. Similarly, if we talk about the digestion process, we consume the food and then we intake energy from that food. That is also possible because some chemical reactions are happening in our body. Similarly, the process of respiration. What do we inhale? Which gas do we inhale from the atmosphere during respiration? What do we need to survive? Anyone? Yes, oxygen. What do we exhale?
Carbon.
Dioxide.
Carbon dioxide. So we can observe that something has happened in between. We inhaled oxygen and we exhaled CO2. During this process, oxygen is converted into carbon dioxide. That means for this to happen, there must have been some chemical reaction. Is this point clear? The examples of daily life where we can see some chemical reactions happening, that how initial substance have changed into something new. So, Vihan, can you give me some examples of chemical reactions from daily life?
Yes, ma'am.
Yes, very
Met
good.
metal rusting,
Yes,
turning wood into paper,
okay.
and one second.
Try to remember the recent examples we discussed in the class.
Yes, ma'am. Alcohol, grape to
Yes,
alcohol,
fermentation.
fermentation, ma'am, milk
Yes,
curdling,
very good, very good. So,
and
Niharika, can
burning.
you, yes, Niharika, can you give some examples? You can repeat also.
Digestion,
Yes,
respiration,
Yes,
um, and resting, and
very
no.
good, very good. Okay, so you can see these chemical reactions happening in our daily lives. But since we are growing up and we are getting into science, we are going to observe some chemical reactions which are engulfed in this chemistry process, which are very much related to chemistry. That is, you are going to deal with complex reactions, right? So let us see some examples. You are going to do these experiments in your lab, and in exams also, you are going to get questions from these experiments. So, first example that we are going to deal with is burning of a magnesium ribbon. First of all, tell me, do you know about magnesium? Anyone?
Yes, ma'am.
So, it is present there in the periodic table, right?
Yes, ma'am.
Where it is its position. Can you recall? On the left hand side of the periodic table, on the right hand side?
It's 12.
Yes, its atomic number is 12. If you will see in this portion of the periodic table, on the left hand side, here you will see the magnesium. So, what we will do, we are burning a magnesium ribbon, a ribbon made up of this element, magnesium, in air, and then what happens in this, if you will see, this is a magnesium strip. We will see a video for this. First, let me explain what is happening. This is a magnesium ribbon. It is burned in presence of air, and then we see that it burns with a dazzling flame. It burns with a dazzling flame, and then we collect the magnesium oxide in this watch glass. This is magnesium oxide collected in this watch glass after this magnesium ribbon got burned. So, what is this material collected in the watch glass? This is nothing but magnesium oxide. Now we are dealing with chemical reaction where we have converted magnesium into magnesium oxide by burning it. We have done a chemical reaction where we have converted magnesium into magnesium oxide. So let us see. Can everyone see the video?
Yes,
Yeah.
ma'am.
Okay. So here
Yes, ma'am.
the strip is the magnesium strip. We are burning it in presence of oxygen because in air oxygen is present and oxygen is the agent which helps in burning. So try to recall this that we are reacting magnesium with oxygen in the air to form magnesium oxide. This is the chemical reaction that is happening.
till it gets a shiny silvery color.
So this is unburnt magnesium ribbon. That is, we have taken a small piece of magnesium ribbon. This is a metal and it gives a silvery luster. Then what we will do? We will hold it with help of this tong we will call, you will use it in lab, and we will burn it. Then after some time we will observe that after catching fire, it burns with this dazzling light. Remember this characteristics that magnesium burns with dazzling light and it forms this powdery ash-like substance. What is this powdery ash-like substance? Anyone? What we
Magnesium
are
oxide.
converting
Magnesium.
Yes, very good.
Magnesium oxide.
Yes. So we have converted magnesium into magnesium oxide through burning it in presence of air. So that is a reaction has taken place. So what are the observations? That magnesium takes some time to catch fire, then it burns with dazzling light and it produced a white powder ash called magnesium oxide. So if we note down, what are the observations? We will do three key observations that it burns with dazzling light, and then second that magnesium oxide, a powdered ash is formed. These are the two key observations that we are observing in this reaction. So can anyone tell me what are the observations, two key observations?
Ma'am, magnesium gives out a dazzling white light while burning.
Yes,
Ma'am,
magnesium burns with dazzling light. You must have seen in the
ma'am,
video what dazzling light looks like. And then next, what is the product?
it leaves a product like magnesium oxide, MgO.
Yes, powdered ash substance called magnesium oxide is formed. We will write the reaction after learning the way to write the reaction. Till now, we know that we used some magnesium, we used oxygen, we reacted them and formed a new product, magnesium oxide, which looks like this. So everyone is clear with this example of the chemical reaction, right?
Yeah, ma'am.
Okay. So next example that we are going to deal with is we are reacting zinc. This is also a metal you can see in the periodic table around the center of the periodic table, a bit right around the center, like in the D block. If you know the D block, we can see the metal zinc. It is represented by symbol Z. So what we will do, we will take some zinc granules. Like magnesium was present in the form of ribbon. Similarly, zinc also is present in form of small granules. These pieces. For example, here you can see these pieces of zinc granules. And then we will react it with dilute sulfuric acid. Can anyone tell me the formula of sulfuric acid if you remember? Sulfuric acid,
H2SO4.
H2SO4. So we are going to use dilute H2SO4 and mix it with zinc granules, and we will observe that some reaction has happened. As a result, we will see when zinc granules react with dilute sulfuric acid, it results in release of hydrogen gas. If we will observe simply, these are the zinc granules, zinc reacting with dilute sulfuric acid. This is the liquid form. What we will see that hydrogen gas emitted. So this is example of another chemical reaction that we have observed. So we have seen two chemical reactions. Next chemical reaction, if we'll see, what we will take.
Ma'am,
These
lead
names may be
nitrate.
new. Yes, we will take lead nitrate solution. Since we are taking solution, we have made the solution of this powdered lead nitrate. So it will look like this water solution only. When, for example, the salt is solid, but we when dissolve it in water, it becomes a salt solution. Similarly, we have made a solution of the lead nitrate, and this has become lead nitrate solution. We have taken lead nitrate in this test tube, and then we have also taken
Ma'am, potassium
potassium,
iodide.
yes, potassium iodide solution. So, Varun, what is the formula for potassium iodide?
Ma'am, Ki.
Ki. What is the formula for lead nitrate? If you can recall.
Ma'am, PbNO3 whole 2, ma'am.
Okay, very good. So we are taking these two solutions and we just mixed them. And after mixing, what we observed that we see settlement of white, there is settlement of yellow colored solid beneath this in the lower part of this test tube. And there is clear solution on the upper side. That means some chemical reaction has taken place where a new substance in the form of precipitate has formed. This is our observation that we see formation of a precipitate which is yellow in color and along with the clear solution. That means some chemical reaction has taken place. If we see the reaction, you can simply observe
हमने
this.
जो है बीकर के अंदर लेड नाइट्रेट का एक्वा सॉल्यूशन
We have taken these two solutions. One is lead nitrate in the beaker below, and from above we are adding potassium iodide solution. On mixing, what happens? You can observe the solution has turned yellow. That means some yellow color new product is formed, and after some time, the yellow color solid will settle down, and on the upper side, we will see the clear solution. So, is this reaction clear?
Yes, ma'am.
Okay. So, Harshit,
Yes, ma'am.
can you give me example of chemical reaction, not from daily life, but for some real chemical reactions that we do in labs?
The burning of magnesium we burn as we discussed, and
Yes, very good. Next, Pranav, are you there? Anurag, Anurag, can you hear me? Okay, so we have discussed three types of chemical reactions where we see we have reacted two solutions and new product in the form of precipitate is formed. How we observed that the reaction has happened, we saw that new precipitate has formed. Then for this reaction, we saw that there is release of hydrogen gas. How we will identify that some reaction is happening? We will see that hydrogen gas is releasing. That means we can see a chemical reaction is happening. In this reaction, when yellow precipitate is formed, we can see that chemical reaction is happening. Similarly, in this process, if magnesium oxide, white powder is formed, we can observe that chemical reaction has happened. So, from these three activities, we can say that there are some specific observations which can help us determine whether chemical reaction has happened or not. For example, we are doing this reaction. We are doing this reaction. We are adding zinc granules, dilute sulfuric acid, and we are waiting. We see that there is no release of hydrogen gas. So till that time, we can say that no chemical reaction has happened. But as soon as we see that hydrogen gas is released, we can say that some chemical reaction has happened. So now we can write that there are few observations which help us determine whether a chemical reaction has taken place. For example, change in color. In which chemical reaction we saw change in color? Anyone? Out of the three examples we saw,
Lead
they must have
nitrate
been
Magnesium
solution
solution.
plus
very
potassium
good.
iodine solution.
Where we see from colorless to yellow. By that, we observe that some chemical reaction has happened. So the change in color is one observation that can help us determine whether a chemical reaction has happened or not. Next is evolution of a gas. So Niharika, in which reaction did you see that there was evolution of gas?
When you mix zinc granules and sulfuric acid.
Very good. When we mixed zinc granules with sulfuric acid, there was release of hydrogen gas. And that showed that some chemical reaction has happened. Some other observations also that we will see in different types of chemical reactions in future examples is change in temperature. What happens sometimes? For example, there is beaker where we are carrying out some reaction. And if we observe that when we have carried out the reaction and if we try to hold the beaker, it will be it will become difficult to hold it because the temperature of the beaker is very high. Because during the reaction, some heat got evolved and it heated up the beaker. So this also shows this change in temperature is also an example of some observation which help us identify whether a chemical reaction has happened or not. Then change in state. For example, the type of state of milk and curd is very different. Milk is completely liquid while curd is not. So this change in state also shows that this is a type of chemical reaction. So there can be a direct question in the exam that how can you identify whether a chemical reaction has happened or not? So there you will give example. You will mention that we can identify that a chemical reaction has happened or not based on the basis of whether there is change in color, whether there is evolution of any gas, whether there is change in temperature, or there is change in state of the reactants or the products that we are taking. And then you can give examples also. For example, in change of color, you can give example of reaction of lead nitrate with potassium iodide. Here, zinc granules with dilute sulfuric acid. So these examples you can give along with these points that these observations are can be seen during chemical reaction. Now, is this everything till this point? Is it clear to everyone?
Yes, ma'am.
Is there
Yes,
is
ma'am.
there any doubt? Yes. Any doubt till this point?
No, ma'am.
Okay. Okay. You can ask question in between also. If you have any doubt, you can stop me and ask the question, okay? Then moving on to the name of a chapter itself. Chemical equation. So for example, when we saw magnesium ribbon burning in presence of oxygen, it converted into magnesium oxide. So there are so many reactions of this type. Every time we are not going to write magnesium ribbon burning in presence of air results in formation of magnesium oxide. So this way we are not representing the chemical reactions or equations. So this description in form of sentence is quite long. So to write it in shorter form, we use chemical equations. So first we will discuss about word equation, where we are writing chemical reaction in form of words. It is very simple. First of all, tell me, what do you mean by reactants? Anyone?
Ma'am, the chemicals which contribute to make a equation.
Yes. So in equation, there are products also, there are reactants also. But what we take initially, what we have, for example, in the reaction magnesium ribbon burning to form magnesium oxide, what we had initially, magnesium ribbon or magnesium oxide,
Ma'am, magnesium ribbon.
magnesium ribbon. So the reactant is magnesium ribbon. Also, we had the air, we had oxygen, right? So both of these are reactants. And what is formed? When these reactants combine in different forms or they react, they form products. For example, magnesium oxide. So, what is the convention? On the left hand side,
Ma'am, magnesium oxide
yes,
on product side.
yes, very good. So, on left hand side, we will always write the reactants. We will indicate, use an arrow in between to show that product is formed and the product would be written on the right hand side. So, for example, if I write that there is magnesium, it is reacting with if there are two or more reactants. if two or more reactants or products. We separate them using symbol plus. For example, in the case where we are reacting magnesium with oxygen to give us product magnesium oxide, we have two reactants, the magnesium and the oxygen which is present in the air. So we have two reactants which are present. They reacted to form product magnesium oxide, which is only one, so there's no need of any plus sign on this side. And this is example of word equation. So now we can write definition for reactant also. So reactants are the substances that undergo chemical change in the reaction. Reactants are the substances that undergo chemical change in the reaction. Here magnesium oxide is getting formed. It is not going any resulting in any change. What is changing is the characteristics of magnesium. It is a simple magnesium ribbon right now. It combined with oxygen and gave us new product. So these substances, magnesium and oxygen, are example of reactants that undergo some chemical change in the reaction. So here you can write example magnesium, oxygen. So a word equation. Now, can you tell me definition of product? Anyone?
The
What
substance
could?
formed after a chemical reaction is known as the product.
Yes, very good. So product, main point that we have to remember about product is it is the new substance. It is the new substance that is formed during chemical reaction. Example, magnesium oxide. So now we know what is reactant, the substances that undergoes chemical change. Remember this definition, reactants are the substances that undergo chemical change in the reaction. Here the example is magnesium and oxygen. And product is the new substance that is formed during chemical reaction. Example, magnesium oxide. Then we form a word equation where it shows change of reactants to products through an arrow placed between them. So this arrow shows us the direction of the reaction. So which component in the word equation shows the direction of the reaction? It is the arrow. It shows that these are the reactants. These are changing into products. This arrowhead is on the side of products. And this arrow showing the direction of the reaction. The reactants are written on the left hand side. Products are written on the right hand side. Reactants on left hand side, products on the right hand side. Okay. So Anurag,
Yes, ma'am.
okay. So Anurag, can you tell me on which side reactant will be written in the word equation, on which side product will be written?
Ma'am, reactants will be written on the left side, products will be written on the right side.
Yes. So what do you mean by products?
Ma'am, the new substances that is formed during a chemical reaction.
Very good. Now, Aksh, are you there?
Yes, ma'am.
So what do you mean by reactants?
Ma'am, the chemical substances which combine to form the new substance is called the reactants.
Yes. Yes, you can write this definition also, or the substances which undergo chemical reaction, you can write this way also. Okay. So the meaning is same that these are the substances which are undergoing some change to form new products, and the new product which is formed is the product.
Okay.
The new substance which is formed is the product, and the things which are getting reacted is the reactants. Okay, very good. But every time writing in the form of this word equation, this is example of word equation. This also is not, you know, preferred by the scientists or people who use chemistry in daily life. So they use even the shorter form to write these chemical equations. And for that, you must know the chemical formulas first. So to make chemical equations even further more shorter or more concise,
Ma'am,
so
ma'am,
what we
can you
can
go to the
use,
previous slide?
yes, okay.
Done, ma'am.
Okay. So instead of words, what we will use chemical chemical formulas. Instead of writing whole magnesium or magnesium oxide, we will write their short form, that is their chemical formula. So this will be a chemical equation representing a chemical reaction in shorter form, in form of symbols. That is symbolic representation. So if we write the definition of chemical equation, not in the form of word equation, how can we write it? The key point must be that it is the symbolic representation of a chemical reaction. So, if we write about chemical equation, we will say that it is the symbolic representation of a chemical reaction. Till now, we were writing words for chemical reaction. Now we will use only the symbols to represent the reactants and the products. It is the symbolic representation of a chemical reaction in form of chemical formulas. So we have studied the burning of magnesium ribbon. The chemical formula for magnesium is, what is the chemical
Ma'am,
formula for
Mg.
magnesium? Mg. Very good. Then what is the chemical formula for oxygen?
Ma'am, O2.
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 Very good. The chemical formula for magnesium oxide.
Ma'am, MgO.
Everyone agreeing with this?
Ma'am, it would be MgO2.
Okay. Anyone else?
Ma'am, it's MgO only.
Okay. So you know about this. Magnesium existing in magnesium 2 plus and oxygen existing as O2 minus. Do you know about this?
Ma'am, both will get neutralized.
Yes, ma'am.
Yes. Very good. So this will not form Mg2O2 or MgO2. The formula will be MgO. Okay. So these formulas you'll have to remember correctly. You cannot write any combination. Otherwise, your chemical equation will be wrong. So now if we start writing our chemical equation, on the left hand side, we are going to write our reactants. Then we indicate the direction and then we will write the products. Here we have reactants as magnesium and oxygen, product as magnesium oxide. So we will write magnesium reacting with oxygen, changing into magnesium oxide. Below this, we can mention their name if we want to. So on left hand side, reactants. On right hand side, product. Reactants, if they are more than one, we separated them using the symbol plus sign. So this is example of chemical equation where magnesium reacting with oxygen to give magnesium oxide. Do you know some famous example of any chemical reaction or chemical equation that you must have studied in lower classes that
This
you remember?
hydrogen and oxygen gives H2O.
Hydrogen and oxygen, hydrogen
Plus oxygen gives water.
giving water. Very good. Now tell me formula for
Ma'am,
each of these. Yes, nitrogen,
nitrogen and chlorine.
chlorine.
Salt, common salt.
Was this nitrogen?
No, ma'am,
It's sodium.
sodium. Sodium plus chlorine is common.
So this was sodium. You must be confused because the symbol of sodium starts with N. It is Na. So you shouldn't be confused with this. Okay, so write clearly that sodium is Na. For nitrogen, the symbol is N. For sodium, the symbol is Na. And we will form the common salt. Any other reaction that you can recall?
Ma'am, quicklime.
Yes. Someone was saying some reaction.
Ma'am, quicklime, ma'am.
Okay, quick line. Got it. We will study that in detail. Have you heard of
Rush,
photosynthesis?
iron
Yes.
and hydrogen.
Iron
Oh,
and hydrogen. Where did you study this reaction?
Ma'am,
no,
ferrous,
iron,
rusting.
iron and no, I said rush. No, I have a doubt.
Rust.
Like
Okay.
iron and hydrogen or iron and like oxygen rush.
It is, we will discuss this concept in detail, but it is iron plus oxygen
Okay.
because you must have studied in lower classes also. That is, it is oxidation of metal that causes corrosion, not hydration of metal. So in oxidation, we add oxygen to the metal,
Ma'am,
not
ma'am,
hydrogen.
ma'am, I guess in rusting, water is also involved.
So yes, water is also involved. It is air that is also involved. Oxygen gets added. So
Ma'am,
presence
so
of both of
then
these.
in the reaction, you should also get water, right?
Yes, we in the reaction we add oxygen, we add moisture. Moisture is nothing but water only. We will discuss
Ma'am,
corrosion in detail. Okay, that is a
ma'am,
complex formula. You will get confused. Yes, yes,
ma'am, but according to the equation, ma'am, ferrous plus oxygen is gives rise to ferrous oxide, right, ma'am? Ma'am, water
yes.
is not involved, right?
See, this is a very complex reaction. You will be confused if I discuss this now. Have you heard of these dot H2O hydrates?
No, ma'am.
No, you haven't, right? So I am not going to discuss this right now, otherwise you will get confused. But for now, for the simple form of the reaction, for the simplest form of the reaction for rusting, for now you have to remember that it is iron plus oxygen changing into ferrous oxide. Okay? This is the main or basic reaction for rusting. How other factors, moisture, air present, how that affects, plays a role in rusting. But defining it in reaction is till now we cannot do it because that is not you have been taught till now. You will study the complex reaction in detail in higher classes, okay? So have you heard of photosynthesis reaction?
Yes,
Yes,
ma'am.
ma'am.
Okay. So what combines in photosynthesis reaction? It is a reaction where plants used to make their food, right?
Yes, ma'am.
So what happens in photosynthesis reaction? Which gas plants inhale?
Ma'am, CO2.
It is carbon.
Ma'am, CO2.
Yes,
Ma'am,
carbon dioxide.
usage of water and sunlight.
Yes,
Yes, ma'am.
there is water,
Ma'am, it gives rise to C6H12O6 glucose.
glucose,
Ma'am, plus oxygen, I guess.
oxygen that is consumed by human beings, right? That is why we say that plants are important because they release oxygen, which is used by us for respiration and other things. Our body perform all the metabolism on basis of the reactions done using these oxygen. So we have written word equation. Now, Pranav, Pranav, are you there? So if we try to write word equations for this, what is the symbol for hydrogen gas that we use?
Ma'am, H.
H.
2. H is symbol for hydrogen alone, that is an element. But in atmosphere, H alone will never exist.
Ma'am,
It,
H2.
it exists in form of H2 gas. So we will always write H2 for hydrogen. What we will write for oxygen?
Ma'am, O2.
O2. What is the formula for water?
Ma'am, H2O.
H2O. So
Ma'am,
H2 will combine with O2 to give H2O. Yes?
ma'am, a few times we also write as 2H2O. Why?
Yes. That is the next topic that we will deal. We have just discussed how to write chemical equation, but these chemical equations that we have written, they are not completely correct. There is some
Ma'am,
imbalance
we
in
should
these chemical.
balance it. We should
Yes,
balance it.
yes. So after learning to write how we can write these chemical reactions, then only we can balance, right? First of all, you must know the formulas. For example, for balancing, what if you write H2 plus O and changing to H2? Before learning balancing, we need to know the correct formulas before. You cannot write like this, right? So what is the formula for sodium? It's Na.
Ma'am, Na.
What is the symbol for chlorine?
Ma'am, Cl.
Yeah,
Ma'am, NaCl.
Yes,
NaCl.
ma'am, Na.
For carbon dioxide, what is the formula?
Ma'am,
CO2
CO2.
CO2
plus H2O.
plus H2O.
Yes, very
Ma'am,
good.
plus
Formula for
C6,
glucose
C6, C6
H12O6.
H12O6
and then
O2 O2.
oxygen. So we have learned to write word equation. We have learned to write a chemical equation in the form of symbols. But these chemical equations are not perfect. They are not correct until unless we balance them. The number of the atoms on the left hand side and the right hand side. So that we will discuss in detail in the next class, and that is very important topic. In exams also you will get direct questions where you will have to balance. You will be given word equations. First from that you will have to make the chemical formula, the correct chemical formula, and then balance them. So we will learn that balancing in next class. Okay, any doubts till now?
No, ma'am.
Anyone?
No, mom.
So you learned something new?
Ah, yes, ma'am.
Yes, ma'am.
Okay, okay, very good. So note down these definitions, clear and concise, and revise them for the next class. Okay?
Okay, ma'am.
Okay, then, and please switch on your videos. See, the students who had their videos on, they were participating well, and it will help you only in long run. Okay? Okay, then we can end the class if there is no doubt.
Sure,
Please
ma'am.
revise the class properly for the next class.
Thank you, ma'am.
Okay.